Today we are going to learn about advanced heat maps with Seaborn, techniques and tips. You will gain skills in creating, customizing, and interpreting heat maps to highlight significant data trends effectively.
Welcome to our video on advanced heat maps with Seaborn. Heat maps are a versatile tool in data visualization, allowing us to represent data density and relationships in a matrix format. These visualizations are widely used in fields such as genomics, where they can illustrate gene expression patterns, and in finance, where they can highlight correlations between different financial instruments. In this video, we will dive into the techniques and tips for creating insightful heat maps using Seaborn, a powerful Python library. Seaborn makes it easy to create beautiful and informative heat maps, and by the end of this video, you'll have the skills to customize and interpret them effectively.
Heat maps are a type of data visualization that allows us to represent data values with color. They are particularly useful for showing data density or relationships within a data matrix. A typical heat map consists of a grid where each cell represents a value, and the color of the cell indicates the magnitude of the value. This makes it easy to see patterns, correlations, and outliers in large datasets. Heat maps are commonly used in genomics to visualize gene expression data, in finance to observe correlations between stock prices, and in marketing to analyze customer behavior patterns. The major advantage of heat maps is their ability to present complex data in a visually intuitive manner. In this section, we'll explore some examples of heat maps from various industries to understand their versatility and significance. Before creating a heat map, it's crucial to prepare your data properly. Data preparation involves cleaning the data by handling missing values and ensuring accuracy. Missing data can skew the results of a heat map, so it's important to address these gaps. You can choose to fill missing values with a specific value or remove the affected rows or columns. Normalizing the data is another important step, especially when you're comparing values across different scales. This ensures that each value is represented proportionally in the heat map, allowing for accurate comparisons. Selecting the right subset of data for visualization is also key. Too much data can clutter the heat map, while too little may not provide enough information. Ensuring that your data is accurate and well prepared is the cornerstone of creating an effective heat map. Once your data is ready, you can start creating heat maps using Seaborn. First, ensure you have Seaborn installed in your Python environment. You can do this using pip install Seaborn. Next, import Seaborn alongside other libraries like matplotlib and pandas for data manipulation and plotting. To create a basic heat map, you'll use the seaborn.heatmap function. This function takes several parameters, but at its core, you need to provide the data you want to visualize. A basic example would be sns.heatmap data, where data is a pandas data frame. The output will be a simple heat map, which you can further customize. Understanding the default output and learning how to adjust basic settings like the color palette, line widths, and labels will set the foundation for more advanced customizations. Colors are an integral part of heat maps as they convey the data's magnitude. Seaborn offers a variety of color palettes that you can use to customize your heat map. Choosing the right color palette is essential for clarity and effective data interpretation. You can use sequential palettes for data with a single range and diverging palettes for data with a midpoint. Adjusting color intensity can help enhance the visibility of subtle differences in the data. Seaborn provides the CMAP parameter in the heatmap function to specify your color palette. For example, sns.heatmap data, CMAP equals cool-warm, uses a diverging palette. Balancing aesthetics with clarity is key, as a visually appealing heatmap that is difficult to interpret defeats its purpose. In this section, we'll explore different techniques to customize color scales for better data representation. Annotations add another layer of information to your heat maps, making them more informative and easier to interpret. By default, heat maps show data value intensity through color, but adding data labels can help viewers understand exact values. Seaborn allows you to annotate heat maps using the onNote parameter. For instance, sns.heatmap data, onNote equals true, will add the data values as text on each cell. You can further customize the font size and style using the FMT parameter for format specification. It's important to ensure that annotations do not clutter the heat map. They should provide additional context without overwhelming the viewer. In this section, we'll discuss best practices for annotating heat maps to improve their readability and effectiveness. Missing data can disrupt the patterns and insights a heat map is supposed to provide. It's crucial to handle these missing values appropriately to maintain the integrity of your visualization. Several techniques can be employed, such as imputation, where missing values are replaced with estimates based on other available data, or simply removing the affected rows or columns if they do not significantly impact the dataset. Seaborn handles missing data by default by not displaying them, but this can lead to gaps in your visualization. It's important to address these gaps to ensure your heat map remains informative. In this section, we'll explore how to use Seaborn and other methods to manage missing data effectively. Clustering techniques can significantly enhance the insights you gain from heat maps. By grouping similar data points, clustering can help identify patterns and relationships that might not be immediately apparent. Hierarchical clustering is a popular method used with heat maps. Seaborn offers support for clustering with the clustermap function, which not only generates a heat map but also includes dendrograms that show the hierarchical relationships between data points. This can be especially useful in fields like genomics, where understanding the relationships between genes is crucial. Clustering enhances pattern recognition and provides a deeper understanding of the data structure. In this section, we'll demonstrate how to apply clustering techniques to your heat maps, leveraging Seaborn's capabilities to uncover hidden insights. Presenting heat maps effectively in reports requires careful consideration of your audience and the message you want to convey. Tailor your heat maps to ensure they are both informative and accessible. Avoid overloading your heat map with too much data, as this can overwhelm viewers and obscure important insights. Simplify where possible, focusing on key data points that support your narrative. When incorporating heat maps into presentations or reports, ensure they are clear and visually appealing. Use appropriate color schemes and provide annotations or legends to guide interpretation. Accessibility is also important. Consider colorblind-friendly palettes and ensure text is legible. In this final section, we'll cover best practices for presenting heat maps, helping you communicate your findings effectively and leave a lasting impression. Congratulations on completing this tutorial on Advanced Heatmaps with Seaborn. We've explored various techniques for crafting and customizing heat maps, from understanding their applications to handling missing data and enhancing insights with clustering. The ability to tailor your heat maps through color scales, annotations, and clustering techniques allows for clearer data storytelling and more impactful presentations. As you continue to apply these techniques, you'll strengthen your data visualization skills and uncover deeper insights from your datasets. I encourage you to practice these methods and experiment with Seaborn's diverse features to master the art of heat map creation. Thank you for joining us, and happy visualizing.